All right, also, like I said, 8.4 theorems about zeros. All right, so to foil in this section, I'm going to recall y'all on a few things or show you something new. Either way, it is about foiling. So I'm going to foil radicals. So these are what we call conjugate pairs, when the factors look the same other than one's being added and one's being subtracted. So these are conjugate pairs. Now, another thing you'll need to know on this section, when I multiply a radical times itself, so say if I had a square root of A times square root of A, that's just going to equal A. Because square root of A times square root of A would be square root of A times A, which is A squared. But then the square root of A squared gives you A. So when a radical matches and you multiply it times itself, in the long run, it gives you what was under that radical. Now, what I'm going to do is show you the long way on this, and then show you that when you have conjugate pairs, you can do what we call shortcut methods. So we're going to foil this and watch conjugate pairs. You'll notice that every time the middle terms are going to cancel. So y'all watch this. X times X is an X squared. X times a negative square root of 2 is a negative square root of 2 times X. Then I would do the inside. Square root of 2 times X is a positive square root of 2 times X. And then I'll do this the long way. Positive square root of 2 times negative square root of 2 would be a negative square root of 4. But remember over here, I said a radical times itself will basically give me that number that was under that radical. So in a second, when I take the square root of 4, you're going to see all I'm going to get is that 2, okay? So notice here, in the middle, those cancel. Conjugate pairs will always cancel the middle terms. So all that's left is the X squared minus square root of 4, which is 2. Now, when you foil conjugate pairs of radicals like this, it's always going to be minus in the middle, okay? On your final answer will always be minus. So watch this, the shortcut method for conjugate pairs. So say X plus square root of 2 times X minus square root of 2. The shortcut method, since these middles always cancel out, is to take the first two terms, the X times the X, then get an X squared, and then multiply the last two terms. So positive square root of 2 times negative square root of 2 would basically be a negative 2. Okay, so just remember square root of 2 times square root of 2 is just 2 when you multiply that, okay? So that's going by that property. Alrighty, so that's on radicals. So we're going to have to know how to do radicals in a little bit. I'm also going to do a recall on imaginary. So X plus 3i times X minus 3i. So the big thing on here, these are still conjugate pairs. One's being added, one's being subtracted, but everything else is the same. So the star you want to know on this section is about an I squared. Well, let's let me pull up my calculator and I'll show you what I squared actually equals. So on your calculator down here by the zero, over here by the decimal, there's an I above it. So if you hit the second in the decimal, that brings up the I. And I'm going to multiply that times itself, which would be the same as I squared. Now notice what you get when you do an I times an I. Whoops, let me fix my mode. Oh, let me go down here and put this back on. So it's giving me -1 plus 0i, which basically is a -1. So let me show you a second. I square that. I still get that -1 plus 0i. So that means anytime I get a negative, I get an I squared, I will replace the I squared with a -1, okay? Now, I'm going to do this the long way to show you that the stuff cancels still and show you that you could shortcut this one also. Any conjugate pairs we can do the shortcut for to them, okay? All right, so here we go. X times x, x squared. X times -3i is a -3ix. 3i times x is a positive 3ix. And then that 3i times -3i is a -9i squared. So if you notice in the middle, those cancel. And the I squared, we're going to replace it with a -1. So basically, all I squared does is change the sign of the number in front of it. Because now a negative times a negative is going to make that a +9. So that this gives me an x squared plus 9. So anytime you FOIL imaginary numbers that are conjugate pairs, it's going to end up x squared plus that number. Radicals will give you x squared minus that number. All right, so remember, I said you could have shortcutted this. So you could have did x times x and got x squared. 3i times -3i gave you -9i squared. But remember, you got to replace the I squared with a -1 so that this becomes x squared plus 9. Okay, so anytime you got an I squared, get rid of it and change the sign of the number in front of it. So what we're going to start out with is finding polynomials given the zeros. So we're going to find polynomials given the zeros. So my first one, they want me to find a polynomial of degree 3 with zeros of -2, 3, and -6. So now here's a trick. They're saying find a polynomial of degree 3. That means when I'm done with this polynomial, it has to have an exponent 3 as the largest exponent. And y'all usually remember the degree also tells me how many zeros I have. So I got 3 zeros since that was a degree 3. So here's what you do. The first step, we're going to write these as factors. So remember one thing. The factors have opposite signs than the zeros. So I've got 3 zeros, so I need to write 3 sets of parentheses for my factors. All right, so the 0 of -2, that factor would be a x plus 2. The 0 of 3, that factor would be a x minus 3. The 0 of -6 would give me a x plus 6. So as many zeros you have is how many factors you'll have, and the factors have to have opposite signs than those zeros. All right, so we've got our factors. So now to get that polynomial, we need to start multiplying. So what I'm going to do, I always start with the last 2. And we're going to FOIL those. So I'm going to bring down the x plus 2 in the front. And I'm going to FOIL this to get my next step. So FOILing this, we got an x times x is an x squared. X times 6 is a 6x. -3 times x is a -3x. -3 times 6 is a -18. So before I start again, can I do anything in this to simplify that maybe a little further? All right, so let me get my chat box pulled up. So yeah, we definitely can. We got like terms in there. So let's add them like terms real quick. So bring down my x squared. Let's see, 6 minus 3 gives me 3 x's. And then minus our 18. So now that we got this one FOILed, now we need to FOIL this whole thing. So take this x times all 3 of those, and then we'll take the 2 times all 3 of those. So the x times x squared is an x to the 3rd. So remember, since I'm multiplying these x's, I'm adding those exponents. X times 3x would be a 3x squared. X times a -18 is a -18x. So I distributed my x. Now I got to distribute the 2. So 2 times x squared is a 2x squared. 2 times 3x is a 6x. And then 2 times -18 is a -36. All right, so our multiplying's done. And I'll show you a trick. When you had 2 things times 2 things, you had 4 terms at first. When you have 2 things times 3 things, you got 6 terms at first. And y'all guess what? I got to add like terms. So let me bring down my x to the 3rd. My 3x squared will add to the 2x squared. So that'll give us 5x squared. My -18x will add to the 6x. So -18 and 6 give us a -12x. And then at the end, bring down your -36. So remember, they said I needed a degree 3. My highest exponent is a degree 3. So y'all, that's going to be the trick. Get your zeros, put them in factor form, changing those signs, and then it's just starting to FOIL these, okay? So y'all got any questions on that one? All right, here's going to be a trickier one. Now, this one don't tell you what degree you need. It just says write a polynomial. With zeros of 3, 6i, and negative 6i. So here's the thing about the imaginary zeros. The imaginary zeros will always come in conjugate pairs. So if you got a 5i, you're going to get a negative 5i. If you got a 12i, you're going to have a negative 12i. They always come in conjugate pairs like this, okay? So guess what? We got 1, 2, 3 zeros. That means our highest exponent when we're done has to be x to the third, okay? All right, so let's write it out. We got 3 factors. So from the 3, I'm going to get x minus 3. The 6i is going to give me a x minus 6i. And then the negative 6i is going to give me an x plus 6i. So y'all with me? All you're doing is changing these signs to get your factors, okay? So once you got your factors, it's just a matter of foiling again. On this one, now normally it wouldn't matter which 2 you foiled first, but since these are conjugate pairs, I would definitely foil those imaginary ones first, or it'll get sort of ugly if you started with the first 2 on this, okay? And on this foil, I'm going to shortcut it. So bring down that x minus 3. So remember, shortcut on conjugate pairs, I can do the first 2, x times x, which will give me an x squared. And then I can do the last 2, negative 6i plus 6i gives me a negative 36i squared. So let me ask you this. Can I go further with that before I foil again? So y'all were saying yes, right? Yes, definitely, because remember, that I squared is there, and I squared really equals a negative 1. So I'm going to get that all changed before I foil. So bring down your x minus 3. And this one will be what? An x squared. Negative 36i squared will now become a positive 36. So remember, when you foil conjugate pairs of imaginary numbers, they always end up positive, okay? All right, so now, and what else is neat about these? When you foil those imaginary numbers, all the I stuff goes away. The I's are gone. So all we got to do is foil this. And once we foil that, we will be done. Now remember, these are not conjugate pairs, so I got to do the whole long process. So the x times x squared will give me an x to the third. X times 36 will give me a 36x. On the inside, I got negative 3 times x squared. And then negative 3 times 36 will be a negative 108. So y'all, there's probably one more thing I would do to that. I would probably rearrange this and get these exponents in descending order. So I end up with an x to the third, then my negative 3x squared, then my 36x minus my 108. And look at that, I had 3 zeros. My exponent for my degree is a 3. All right, so same thing, write a polynomial. With zeros of square root of 3, negative square root of 3, and 5. All right, so 3 zeros means 3 factors. And remember, all we're doing is changing the signs, putting them in factor form. So that was a positive square root of 3. This will become a negative square root of 3. This one's a negative square root of 3. It'll become a positive square root of 3. And then that's a positive 5. That will become a negative 5. All righty. For this one, I would start with these radicals again, because remember, conjugate pairs of radicals, when you FOIL it, we'll get rid of the radicals, okay? And I'm actually going to FOIL it with the shortcut. Since it's conjugate pairs, we're going to shortcut this. X times x is an x squared. Negative square root of 3 times positive square root of 3 is going to give me a negative 3. So remember, negative square root of 3 times the square root of 3 is just a negative 3 for that, okay? All right, then bring down your x minus 5. So these are pretty quick if you do the shortcuts on them, okay? All right, y'all. I had 3 zeros, so I got to end up with an x to the third on this. And here I go. X squared times x gives me my x to the third. X squared times negative 5 is a negative 5x squared. Negative 3 times x is a negative 3x. Negative 3 times negative 5 is a positive 15. And guess what? This one's in order. No more like terms. So we are done. So y'all, really the trick on these is keeping up with signs on all this FOILing, okay? All right, so this one says, find a polynomial. Degree 3 with zeros of negative 1/5, 0, and 4. Now, let me tell you something about the 0. When zeros is 0, when you put it in factored form, all this going to give me is an x. Because remember, x plus 0 is just x. So for that 0, I'm just going to put an x over here. And then the other two have numbers. So I will put them in factored form. So I got this one from the 0. Negative 1/5, that'll give me x plus 1/5. And then 4, that'll give me x minus 4. So remember, when you got a 0 of a 0, all you put are x's for that factor, okay? Because x plus 0 would still be just x. All right, y'all, so let me put that down a little. So now our trick is to FOIL. So I'm going to start with these two here. Because when I'm done that x, I'm just going to distribute it through whatever I get. So bring down this x. And let's see what we get inside our parentheses. So x times x is an x squared. So I'm just going to FOIL this one again. X times negative 4 is a negative 4x. Then you got a 1/5 times x, which is a positive 1/5 x. 1/5 times negative 4, that's going to be a negative. Now remember, when you do 1/5 times that negative 4, treat the 4 like it's got a 1 under. and you multiply straight across. So that'll give me a -4 over 5. So I get a -4/5 at the end. And y'all, I got to do one more step before I worry about this x. I got like terms in the middle. A -4x plus a 1/5 x. So -4, I got to figure out what -4 plus 1/5 is going to give me. So let me do it by hand and then I'll show you on the calculator. So by hand, I would probably put a 1 under that, find a common denominator between 1 and 5, which is 5. So to turn this 1 into a 5, I multiply the bottom and top by 5. So I get a -20 over 5 plus 1 over 5. So that'll add to give me a -19 over my 5. So bring down this x squared minus 19 over 5 x's minus 4/5. Now, if you don't like doing fractions by hand, go to the calculator. So the first thing I had to do is figure out what 1/5 times -4 is. So 1 divided by 5, that's my 1/5. Multiply that by a -4. Now I get a decimal, so to turn the decimal back into a fraction, hit the math button and enter twice. And there's my -4/5 I got for multiplying. Then I had to add a -4 plus 1/5, which would be 1 divided by 5. So that gave me -3/8, but remember, hit math and enter twice. And there's my -19/5 we got. All right, y'all, so going back. So no more like terms. So my last step, distribute that x through there. So I get an x to the third. X times -19x is a -19/5 x squared. And then x times that -4/5 is a -4/5 x. So basically, when you distribute a single x, you're just adding the x to everybody. And y'all can't go no further, so final answer. So the trick is, remember, when you've got a 0 of 0, you just put x's for that factor. Everything else that's a number, change the sign, put them in those factors, okay? All right, y'all, so let me move my camera back up. Same type of problem, but they're using different wordage on this one. So find the polynomial degree 6. So polynomial degree 6 with -2, a 0, multiplicity 3. Then it says 0, a 0, multiplicity 2. And 2 is a 0, multiplicity 1. So it's a degree 6 polynomial, but look at this, 3 of these, 2 of these, 1 of these, that makes 6 different zeros. So the trick is writing these out. So the -2, 3 times, that's going to give me 3 sets of parentheses. Remember, 0 is a 0 twice. So for the zeros, I'm just going to add x's. So remember, I'm getting the x's from the zeros here. Since this was -2 3 times, change the sign, you get an x plus 2, x plus 2, x plus 2. And then the last zero was 2, so that's going to give me a x minus 2, and that only had a multiplicity of 1. So y'all with me on that? X's from the zeros. Everything else, I changed the signs and put it down how many times those multiplicities said. So we can do this multiplying real quick, because x times x in the very beginning will give me an x squared. Now, I'm going to FOIL those two first. So let me bring down these other x plus 2s. So y'all, let me ask you this. Do you realize that that x plus 2 and x minus 2, those are conjugate pairs? So since they're conjugate pairs, I'm going to shortcut FOIL. So x times x will be x squared. And then 2 times negative 2 will be a negative 4. So numbers, imaginary, radicals, if they match up and they're conjugate pairs, you can definitely shortcut those. So next, I'm going to FOIL these. And I actually got to FOIL that one out because those are not conjugate pairs. So I'm going to bring down the x squared and the first x plus 2. So we're going to FOIL the x plus 2 times the x squared minus 4. So y'all, you got an x times the x squared, which is an x to the third. X times negative 4 is a negative 4x. 2 times x squared is a 2x squared. And then the 2 times negative 4 is a negative 8. So look at this. There are no like terms in that. Now, I'm not going to worry about putting it in order until I get to my final answer. Because we still got to FOIL this x plus 2 times all of that. So multiply the x times all 4 of those, and then we'll multiply the 2 times all 4 of those. So I'm going to bring down the x squared in the front. Oh, that's a lot of FOILing. So let's see. X times x to the third is x to the 4. X times negative 4x is a negative 4x squared. X times 2x squared is a 2x to the third. So notice I'm just adding 1x to everybody. And then the x times negative 8 is a negative 8x. And guess what? 2 things times 4, that's going to give us 8 terms out here, okay? Now we're just multiplying everybody by 2. 2 times x3 is a 2x to the 3. 2 times negative 4x is a negative 8x. 2 times 2x squared is a 4x squared. And finally, 2 times negative 8 is a negative 16. So I do think I got some like terms on this one. So let me bring down this x squared. All right, so there's only one x to the 4th, so bring it down. At this point, I'm going to put them in order. So let me do my x to the thirds next. For the x to the thirds, I got 2x to the third plus 2x to the third. That'll give me 4x to the third. Let's see, what next? My x squareds. Oh, y'all look at this. Negative 4x squared, positive 4x squared. So the x squareds cancel, they're gone. Next is my x's. I got negative 8x, negative 8x. That'll give me a negative 16x. So let's see, that's that gone. All that's left at the end is the negative 16. All right, my last step is to now just distribute my x squared through here. So x squared times x4 will be an x to the 6th. Remember, that's what I needed because right here they said, hey, I need a degree 6 polynomial. Well, there's my 6. Right, x squared times 4x to the 3rd would be 4x to the 5th. So all we're really doing is adding 2 to all these exponents. Minus x squared times 16x is a 16x to the 3rd. And then x squared times a negative 16 is a negative 16x squared. So I ended up with a degree 6 polynomial, which is what we needed when we had 2, 3 is 5, and that's 6 zeros, okay? Right, y'all. So the very first part of this is a lot of foiling. So then 6 is doing the same thing. So I'm going to time warp up to 7. So let me ask y'all this. So suppose a degree 4 polynomial has zeros of -2, square root of 5, and 11 halves. What is the other zero? So remember, degree 4 polynomial should have 4 zeros. So by what they're giving me, can y'all tell me the other zero? So y'all need a clue on this one, right? So here's my clue. One of these 3 zeros should come in conjugate pairs. Well, what's that? Negative square root of 5? Perfect. Negative square root of 5 is definitely the other zero. Good job. So let's see how y'all do on this one. So once again, degree 4 polynomial has zeros of I and 8 minus square root of 11. What are the other zeros? Well, remember, that's a degree 4, so it should have 4 zeros, but y'all, they only gave me 2. So any guesses? So I don't see no. So square root of 11. Okay, so this is actually like one number. So it should be a plus square root of 11. So good job. Just want to make that 11 positive. Remember, this is 2 zeros. This is one of those complex numbers like you sort of get when you do the quad formula. So, and notice the only thing that changes sign is the radical part of it. So 8 plus square root of 11, bam, negative I. There you go. Well, that's a 1i. Its conjugate would be a negative 1i. All righty, y'all. Then, once they went through that a little bit with you, so I'm going to go to number 10 here. It says find a polynomial of lowest degree with zeros of -4i and 5. So they're really not giving you no clues. They're just saying, hey, find me a polynomial of lowest degree. So this is where we're foiling again, but they're giving me 2 zeros. So let me ask y'all this. Is that all the zeros that I'm using? No, because guess what? If they give you a -4i as a 0, then you automatically have to come in and put a +4i for the 0. So this would be like number 2, except they're only giving you one of the zeros, and you got to know they come in conjugate pairs, okay? So we would make our 3 factors. Now I'm putting that 5 up front because I want them i's to be together. So remember, since that 5's positive, that's going to give us a -5. That 4i is negative, that'll give me a +4i. And then that's positive, that'll give me a -4i. So for 10 and 11, remember, they're only going to give you some of the zeros. You got to know the conjugate pairs are also zeros, and then FOIL this, okay? All right, y'all, so I'm going to shortcut FOIL this because it is conjugates. So I'm going to bring down my x minus 5. So remember, shortcut will be x times x, which is x squared. 4i times -4i is a -16i squared. But y'all remember, we're going to replace the I squared with a -1. So before we FOIL, let's change them signs. So instead of a -16i squared, all I squared did is change that to a +16. And remember, like I said a while ago, when you FOIL the imaginary stuff, it's always going to end up positive, okay? All right, so now 2 things times 2. We're going to come in and FOIL those. So the x times x squared gives me an x to the 3rd. X times 16 is a 16x. -5 times x squared is a -5x squared. And then -5 times 60 is a -80. So y'all, this one I probably would rearrange it to get these exponents in order here. So I'll do an x to the 3rd minus my 5x squared plus my 16x, and then minus my 80. Okay, so 11 will be the same way. Just remember, if they give you radicals in imaginary, you got to use their conjugates, okay? So then now we're about to start using our synthetic division again. So let me show you what's happening here. So this would be number 12. So for the polynomial is a given 0. But they say find the other zeros. So they're giving me f of x equals x to the 3rd plus 4x squared minus 5x minus 20. And then they got a semicolon and a -4. So what they're telling me, they're giving me the 0 of the -4. This is the degree 3, so we need to find 2 more zeros. They're only giving me 1 of the 3. So what we do to find all the zeros, we're going to use synthetic division. So let me show you what we're going to do. The first zero we're going to check is the one they're giving me. That's a -4. My coefficients are 1, 4, -5, and -20. So let's see if y'all remember this. Since they told me this was a 0, what does that mean my remainder has to be when I do synthetic division? It's definitely got to be 0. Good job. Now, what we'll do, we're basically going to divide this 0 out. And what we do, when we get it down to 3 numbers here for the quotient, we can use our quadratic formula to get the last 2 zeros, okay? So you got to get it down to the last 2 zeros. We can always use the quad formula. And we can punch that on our calculator real quick. But this is how you start breaking out these zeros. So remember, bring the 1 down. So synthetic division, 1 times -4 is -4. Then you're going to add 4 and -4. That's going to give you 0. To get the next number, you do 0 times -4, which is 0. So that 0, -5, give me -5. And y'all look at that. -5 times -4 is 20. -20 plus 20 is 0. So we know we've done our synthetic division right because we have a 0 here. Now at this point, since I'm down to 3 numbers, and this started as x3, these now start 1 degree less. So this would be 1x squared plus 0x's minus 5. But at this point, since I got 3 numbers, if you want to, hit that on the quad real quick. So use the quad at this point for last 2 zeros. And you also, let me go to my calculator here. So I think I got my programs on this one. Let me make sure. Yeah, I got quad right there. So hit enter for quad. A was 1, enter. B was 0, enter. C was a -5, enter. Remember, I don't want decimals, so I hit enter 1 more time. And I get 0 plus square root of 5, 0 minus square root of 5. So I'm just going to call that a plus or minus square root of 5. So those are my, now don't put the zeros on MATLAB like the calculator does. Just use the square root of 5 and then a negative square root of 5. So the 3 zeros, they gave you the -4. So I think MATLAB will have you do, use a comma in between it. So just do a square root of 5 and then come in and do a negative square root of 5, okay? But that really should let you use the plus or minus square root of 5. All right, so guess what? They give me a 0. Synthetically divide this. The next quotients are what we use to run the quad. Now, the next one, y'all, I'm going to have a degree 4. So watch what you got to do on this one. So this would be like 13. So for the polynomial, one 0 is given. So we got to find the other zeros. So this one is P of X equals X to the 4th plus 55x squared minus 576. And then they got a quote, semicolon, and they're telling me 8i is a 0. So y'all remember this. I got missing terms here. I don't have the x3 term. I'm going to put a 0 there. I don't have an x term. I'm going to put a 0 there because we need 5 numbers. So let's write our numbers out. We got a 1 for the x4, 0 for the x3, 55 for the x squared, 0 for the x, and then we got negative 576. The first 0 they gave me was 8i. So remember, when we get done with this, we better get a 0 here, okay? Well, y'all watch this. These ain't bad. Bring down to 1. Well, 1 times 8i is 8i. 0 plus 8i is 8i. So look at this. What is 8i times 8i going to give me? So y'all got an 8i times 8i. So that's going to give us a 64i squared. But what's a 64i squared equal? Because remember, that I squared is like a -1. So that's going to become a negative 64. So negative 64 goes here. Hey, but y'all don't worry. Watch this. I got a calculator. So let me clear this. Hit the 8, and then second decimal to get the I, and then multiply that by 8, and then second decimal to get the I, negative 64. Okay. All righty. Negative 64 and 55 give me a -9. Negative 9 times 8i is a negative 72i. 0 plus negative 72i is a negative 72i. And guess what? Negative 72i times 8i is a 500, is a negative 576i squared. But remember, I squared is -1, so that's going to turn that negative 576 into a positive 576. So that would go right here, which means, y'all, when you add that, you do get a 0 remainder. So we knew 8i was a 0. Now, I'm not down to 3 numbers yet, so I cannot use the quad. So I'm going to write these 3 numbers down. Well, these 4 numbers, I mean. And we're going to have to do synthetic division one more time until I can use the quad. Okay, y'all. I need a 0 I can try. So what can I try as my next 0? Oh, good job. It's got to be negative 8i, right? They gave me 8i. Remember, that means negative 8i has to be a 0 if 8i is. Good job. So y'all, let's run that negative 8i. Once we run it through, we'll have 3 numbers here. We can pop it on our quad, okay? So bring the 1 down. 1 times negative 8i is a negative 8i. But guess what? 8i negative 8i? That's going to give you 0. 0 times negative 8i is 0. Negative 9 plus 0 is negative 9. And then to make it official, negative 9 times negative 8i is a 72i. No squares because you don't have an I on both of those. So that'd just be what, a negative 72. Oh, where did I lose my sign at? Oh, that was a negative 72i. My bad, because right here was negative 72. So that last term was a negative 72i. This made a positive 72i. You add them, you get a 0. All right, y'all. 3 numbers here for quad. A is going to be 1, B is 0, C will be negative 9. So let me run that on quad real quick. I'll go to my program, quad enter. All right, so we had a 1 for the A, 0 for B, negative 9 for our C. That's going to give me 3 and negative 3. So if they come out perfectly, we're happy. So for Math Lab, they're going to say the other zeros are blank. Don't forget about that negative 8i, because that was our second 0, then 3, and negative 3. So I'll show you a trick what I could do to this. I probably wouldn't do the whole long quadratic formula because it makes it long. But remember, since these 3 numbers are going to be 1 degree less than the one we just had. So remember, we started out with an x4. This went to an x3. This is now an x squared. So this would be like an x squared plus 0x minus 9 equal to 0. On this one, all you got to do is add the 9 to both sides and then do square roots. So you get your x. Remember, when we do square roots now, we do the plus or minus, and then the square root of 9 would have been the 3. Okay, so yeah, program should go into TI-83, but if it's the old one, you won't have the right kind of cord to get to that computer. All righty, y'all. Next, they want us to find all possible zeros of a polynomial. All possible rational zeros of a polynomial. So this might not be the actual zeros of the polynomial, but these would be any numbers that are possibilities to be a zero of it, okay? They're doing this that way. If they don't give you those zeros like they did a while ago, we could figure out numbers that we could use for the zeros and then do the synthetic division. And remember, if that number is a 0, then my remainder from synthetic division would be 0. So I use what we call a P over Q, plus or minus P over Q, where P is all factors of the last number, Q is all factors of the first number. So we figure out all the factors of the last number, all the factors of the first number, and then we just figure out how many ways we can divide those. So watch this. This will be like y'all's number 14. Find all possible rational zeros of P of X equals 14x to the third minus 34x squared plus 42x minus 15. So this is probably where they get that know your P's and Q's stuff, okay? So let me figure out what is my P and what is my Q. So my P is the last number, so that's 15. My Q is the first number, that's 14. Now I'm not worried about that sign because this plus or minus is going to take care of any signs, okay? So what we want to do now is figure out what are the factors of the 15. Because remember, we got to figure out all factors of the last number, which is 15. So we got 1, 3, 5, and 15. So 1 times 15, 3 times 5. The only way to get a 15, 14 would be a 1, a 2, a 7, and a 14. So we have all the factors. So what I need to do now is take all the factors of this first, of the last number here, divide by every one of these factors of the Q. So they're going to be plus or minus. So I'm going to start with 1. So I'm starting with the 1 here. I now have to divide that 1 by all 4 of these numbers. So I got 1 divided by 1, 1 divided by 2, 1 divided by 7, and 1 divided by 14. Now I take the next factor of the last number, 3, and I divide by all 4 of these factors again. Divide by the 1, divide by the 2, do the 3 divided by the 7, and then 3 divided by the 14. Now we do the next factor, which is 5. So 5 divided by 1, 5 divided by 2, 5 divided by 7, 5 divided by 14. Finally, take the factor 15. 15 divided by 1, 15 divided by the 2, 15 divided by the 7, and then finally, y'all, 15 divided by 14. So these are all the possible zeros for this polynomial. Now, there's a few of these you're going to have to simplify further. Because 1 divided by 1 just gives me a plus or minus 1. The 3 divided by 1 is just a plus or minus 3. That's going to be a plus or minus 5. That'll be a plus or minus 15. So look at this. When they give you this question, they're going to have A, B, C answers on this. So notice I got 1, 3, 5, and 15. So let's see who has that. That's got 1, 3. But notice this one, they don't have the plus or minuses. So they're not counting any of the negative ones that could be. So there's no way it can be C. So let's see what we got here. We got 1, 3, 5, and 15. I need a half, 3 halves, 5 halves. So there's a half, 3 halves, 5 halves, 15 halves. Then I got my sevens, 1 7, 3 7s, 5 7s, 15 7s, and then my 14s. I got 1 over 14, 3 over 14, 5 over 14, 15 over 14. So the one I would go with on that would be like the B here. Let's see what they did here. Oh, they got the wrong denominators here. They're putting factors of the last number on bottom instead of factors of the first number. So remember, it's always the factors of the last number over factors of the first number. Now, y'all, I'm going to tell y'all the truth. when I'm trying to figure out zeros, I'm probably not going to go through that whole process. I'm going to show you on an easy way. But if you didn't have a calculator, that's what you would have to do. So the reason they taught y'all that, here we go. We're going to find the zeros. So find the rational zeros. Then the other zeros. So if you got to use the quad to get those imaginary or the radical ones of the function f of x equals x to the third minus 73x plus 72. Now, after we find all the zeros, then factor into linear factors. They just mean put them in parentheses like we did a while ago when we're for part B, okay? Now, if I was doing what I just showed you, P would be 72. Q would just be a 1 because there's no number there. So the factors of 72 would be 1, 2, oh, let's see, 3 would go. Let's see, 4 would go. 6. Let's see, 7 don't work. 8 will work. So 9. So let me get all my numbers. 12. What? 4 times 18. 3 times what? 24. 2 times 36. And then 72 times 1. So putting all them over 1 will just basically give you a plus or minus 1, plus or minus 2, plus or minus 3, and so on. Now, watch this. I'm not going to go through all these numbers because if I don't get a 0 for my remainder, then I got to try another one and keep doing all that synthetic division until I get a number. Watch this. I'm going to go to my calculator. And I'm going to go to y equals, and I'm going to put in that polynomial. That was the x to the third minus 73x plus 72. So 2 ways you can do this. You can go to the second table and find wherever the y values are 0, or you can try to graph it. So let me see if I can look on the graphs. You know, I can tell this is going across, let's see, negative 1, 2, 3, 4, 5, 6, 7, 8. Looks like it's going to the 0 at negative 9. It's going to a 0 at 1. And then over here at positive 8. And I can verify that by going to the table. So remember, I was at negative 9, I think it was. So at negative 9, my y value is 0. So that means negative 9 is a 0. Look down here at 1, you got a 0. And then I think the other one we said was a positive 8. So those are the 3 zeros for this. So I know my zeros based on the chart. Now, if I was just guessing one of them, let's say I win and I've seen it and I'm going to pick 1. 1 is the first 0, okay? So let me go back to my paper. So now that was pretty easy, but here's what I do. I start with the lowest one. I'm going to try a positive 1 first, then a negative 1. So here we go. We got a 1. There's not an x squared term, so that's a 0. We got our negative 73 and then our 72. If we're right picking that one, that remainder better be 0, okay? So y'all, let's see. Bring down to 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 73 and 1 gives you negative 72. And then negative 72 times 1 is negative 72, which gives me a 0 remainder. So now that this is down to 3 numbers, I can do A is 1, B is 1, C is negative 72. So let's say you got an 83 and you don't have your quad formula. You would do negative B, which is negative 1, plus or minus B squared, which would be 1 squared minus 4 times A, which is 1, C, which is negative 72, all over 2 times A, which is 1. So yeah, you can still do these by hand on the quad formula. So negative 1 plus or minus 1 squared is 1. Over here, 2 negatives will make that end positive. And let's see, what's that going to give me? 288, it looks like. All over 2. So add under the radical. 1 plus 288 is 289. All over 2. Let's see what the square root of 289 is. Whoops, let me get off that page. All right, so square root of when I say 289 is going to be 17, so it comes out perfect. So that this is negative 1 plus or minus 17 over 2. So first answer, second answer, negative 1 plus 17 over 2, which is 16 over 2. So there's the 8 we said on the graph. And then here we would do minus. So negative 1 minus 17 will give you negative 18 over 2, which gives you negative 9. So knock out that first 0 and then get the last 2 zeros using the quad by hand or calculator, okay? And y'all, like I said, that one, all 3 of them were easily seen on the graph. So I want to do one. Now, linear factors, I just want you to put them in parentheses. So we had 1 here, so that would be x minus 1. So remember, change the signs on the zeros. This was a positive 8. That's going to give you a minus 8. Negative 9 is going to give you a positive 9. So this is what they call the linear factors, okay? All right, I'm going to do one more of these. So let's see. This was one of them. All right, let me do one more. And it's going to have an x to the 4th. So this would be like 17. Find all rational zeros. Now for that one, all 3 of them were rational zeros because there wasn't no i's and no radicals, okay? If you get radicals and imaginary, those are not what we consider rational zeros. All right, so this one's going to be f of x equals x to the 4th minus 7x to the 3rd minus 35x squared minus 41x minus 14. Then for part B, factor into linear factors. So my P and Q, P would be 14. Only factors of 14 are 1, 2, 7, and 14. Q would be a 1. And the only factors of 1 are 1. So I would try plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14 for my numbers on this one. So my rational zeros has to be one of those 8 numbers, because remember, all these could be positive or negative. So to get me an idea, I would probably graph that real quick. So let's graph it and see if we can find where we might start on that. All right, so we had an x to the 4th minus 7x to the cubed minus 35x squared minus 41x minus 14. So let's look at the graph, see where we might start on this one. And y'all, it looks like it got a couple here. Looks like it got one at -2 and at -1. So let me go to my graph table and verify that. So let me get up. So -2 and -1 both have zeros. So I know 2 of the zeros out of 4. So let me try the -1 first. Because we're going to have to do a little synthetic division on this in a couple times. Because remember, I'm starting out with the x4. So synthetic division first will get me down to an x3. Then from the x3, I do synthetic division again till we're done. So y'all remember the other zero was what? -2, I think it was. So let me look at that calculator again. So yeah, -2 and -1 are the zeros I'm going to try. And then the last two I'll have to get off the quad. So here we got 1, -7, -35, -41, and -14. If we're right, we will get a 0 here. So bring down to 1. 1 times -1 is -1. -7, -1, -8. -8 times -1, +8. -35 and 8. -27. -27 times -1, +27. So all that negatives, it just changes my signs as I go through. -41 and 27, -14. And here we go. -14 times -1 is a +14 for 0 remainder. So I know my first 0 is -1. Now on the graph, I can also tell that -2 was a 0. But remember now, use these 4 numbers on the next one. 1, -8, -27, -14. Now, once I do this synthetic division, I'll be down to 3 numbers, at which point I'm going to throw them on my quad. All right, so once again, we better get a 0 here if this -2 is right. So bring down to 1. 1 times -2, -2. -8, -2 is -10. Times -2 is 20. -27 and 20 is a -7. And here we go. -7 times -2, +14 gives me a 0 remainder. So my second 0 is -2. Because remember, that's a degree 4. So I need 4 zeros. So at this time, I would hit them on my calculator. So let's go to the calculator and see what it's going to give us. So we're going to clear that, go to program, enter on quad, and I got a 1, -10, and -7. Hit enter. Remember, I don't want decimals, so hit enter one more time. And it looks like I'm getting 5 plus or minus 4 square root of 2. So if you did quad by hand, those are the two answers you'll get. So that my last zeros would be 5 plus 4 square root of 2, and then 5 minus 4 square root of 2. Now, remember I had 4 factors, so I'm going to have 4 sets of parentheses. That's a -1, so that becomes a +1. That's a -2, so that becomes a +2. Now, these are opposite in sign, so you'll notice when you put one in as, now the first one, these are both +5s, so you got to make them both -5s. And then make one of these positive and one of these negative. Okay. So just remember on here, you got to change the 5s to negatives, and then one of these becomes negative, one becomes positive, okay? So that would be your linear factors. So that would be the part B they want. And y'all, once again, they're just doing this so that y'all realize that the factors are always opposite in sign than those zeros right there, okay? All right, so that is 8.4. So it's a little long because you got a lot of pulling you're doing in that beginning. And then most of the end, remember, most of the end was just doing all this synthetic division, okay? So y'all, any questions? Now here's what we'll do. If y'all struggle over the weekend doing the last half of this homework, I will definitely fix y'all Monday when we come back. I'll send you out this video. The first part, we're just doing all the pulling until we get around, what was it, 11, 12, then they start having to find all the zeros. So just remember, on the last 3 problems, if you have issues, use that calculator. Instead of you having to go through synthetic division every time to see if a zero is a zero or not, use the calculator because it can sort of narrow down the choices, okay? Alrighty, so let's see. I'll send this video out after a while. I'm not seeing any questions. So we're all caught up now. So play with your 8-3 and 8-4 for the weekend, and I will see y'all Monday. Is anyone needing any support help?